Hello, folks. Welcome to today's webinar by Planet AI. I'm Dr. Hansi Singh, and today we'll be talking about how real-world weather events emerge in forecasts, and we'll talk about them specifically using three case studies that I think you'll find really interesting and useful. So, a little background on myself. So, I am the founder of Planet AI. I'm an Earth system scientist. I used to work at the US Department of Energy. I was also formerly a professor. I'm still involved in some Earth system model development at NCAR, the National Center for Atmospheric Research in Boulder, Colorado. So, today, we are going to specifically talk about long-range weather forecasts, which we make using Earth system models. And we're going to talk about them in the context of three different major events that I think many of us know about. The first is the LA wildfires and the potential of long-range weather forecasts to predict dry conditions leading up to those fires. The second is the major Grasberg mine mudslide and the excess precipitation that led to the conditions that made that mudslide possible. And then finally, the January 2026 North American Arctic blast. So before we get started, it's really important to say something about how long-range weather forecasting works. How exactly does this work when we're used to generally seeing 7-day weather forecasts on our phone? Well, it turns out that the forecasts on your phone use weather models, which are atmosphere-only models. These predict up to 14 days into the future. And even then, a 14-day forecast, you probably are not going to trust, day 14. This is because the atmosphere has at most a couple of weeks of memory. In other words, it forgets where it started from a couple of weeks into the future at most. If you want to predict beyond that 14-day time horizon, you really need an Earth system model. An Earth system model combines elements from the atmosphere, the ocean, the land, and the ice all together to vastly increase the predictability of the system. In fact, the deep ocean has centuries of memory. So by using Earth system models, we're really able to extend the predictability of our forecasting of the weather. Now, please note, we don't have day-to-day predictability beyond, say, 7 or even 14 days. However, we can tell you whether a given month is going to be, for example, warmer than usual, much warmer than usual, much colder than usual. And we can also sort of give you, say, general risk factors. Like, for example, is this going to be a really major typhoon season, say, over the Pacific Basin? These are the kinds of questions that we can answer using long-range weather forecasts. So the first case study I'm going to go into is that of the Los Angeles wildfires. So these occurred in January 2025. There was a ridiculous amount of damage, over $50 billion. 29 folks lost their lives, 16,000 structures were destroyed, and 57,000 acres were burned over 24 days. These were a hugely consequential event that had knock-on impacts to today. It's only been a little more than a year since this major set of events. So, what were the contributing factors to the LA wildfires? So, first of all, one thing that we do know is that in spring 2024, there was a lot of precipitation in California. And because of that, suddenly, the Hollywood Hills looked lush, which is like really not normal for California. The Hollywood Hills, we're used to seeing them like brown and dry, right? So there was a lot of rainfall. Rainfall led to an abundance of vegetation. Well, over the course of 2024, that vegetation dried out. And in particular, in October, November, and December, often when Californians see some precipitation, we had much drier than usual conditions, which gave even more time for that precipitation to dry out. And then finally, in December 2024 and January 2025, This time of year, December and January, are the peak season for Santa Ana winds. So you put all of this together and you really just have the ideal conditions for a major fire in January, which is exactly what happened. So let's take a look at the rainfall over the course of 2024 compared to usual. So this is the 2024 rainfall in blue, and this is the usual rainfall taken as an average from 1990 to 2025 in gray. And so what we see is here is that excess precipitation in February and March of 2024. And then here are those dry conditions, almost no precipitation leading up to January 2025. So here I'm pointing out October, November, and December in particular, when we often expect to have some precipitation over this region, and we had none. So these were the conditions that led up to the fires in January 2025. So let's start looking at the forecasts. So here what I show are the actual rainfall in October, November, and December of 2024. This is shown in blue, and this is the usual rainfall for that time of year, shown in gray. And this is the forecast initialized in June 2024 for those 3 months. And what you can see is that even in June 2024, significantly drier than usual conditions were being predicted for this area. So the actual precipitation that happened at that time was 0.2 millimeters per day. Usual would have been a little more than 1 millimeter per day. And the average for the predicted value was about half of the usual, 0.6 millimeters per day. So even very early in the year, there was a good indication that we were going to have drier than usual conditions at the end of the year, so that potentially it would be a harrowing fire season. So now let's continue to look at October, November, and December predicted in the months leading up. So earlier we were looking at the June forecast. Let's look at some forecasts that are a little bit closer to October, November, and December. So here what I show is once again October, November, and December rainfall. The actual rainfall is in blue. The usual rainfall for that time of year is in gray. And then a 3 month ahead forecast, a 2 month ahead forecast, and a 1 month ahead forecast in these three colors, orange, light red, and a deep red right here. And so what you can see is that October and November forecasts basically just nailed the fact that it was going to be really dry. In December, the model started to get a little more optimistic for California, though 1 month ahead, they started to get a little more realistic and say, hey, we think there's not going to be that much precipitation. But at least for October and November, we had at least a 3 month ahead lead that these months were going to be dry. And for December 2024, by November, it was starting to become clear to the models that we were going to see drier than usual conditions. So once again, highlighting like forecasting is not magical. It has, pros and cons to it. You can see some really good forecasts. You can see less good forecasts, that take sort of longer to pan out just because there's more physical uncertainty in the system. But in general, these paint a picture of forecasts indicating drier than usual conditions near the end of the year leading up to major Santa Ana wind season. So the key takeaways here are first, there is precipitation forecast skill over California, particularly on the dry side. Drier than usual conditions leading up to the LA fires were evident in the long range forecasts up to 6 months ahead, and that the most challenging to predict were the December 2024 conditions. And I think this could take a little bit more analysis to really understand why December 2024 was particularly challenging. Either way, there was still at least about a month of lead time for December 2024 to really see that it was likely that precipitation was going to be on the low end for that month as well. Let's move on to the second case. So this is the case of the Grasberg mudslide. This happened in September 2025. The Grasberg mine is located in the Papua province of Indonesia, and it is the second largest copper producer on the globe. It is an enormous mine. It is literally visible from space. I was like looking for an image of, the mine, with the mudslide, and I had to look no further than Google Maps because here you go, visible from space. There are some earlier images of astronauts actually taking photos of this mine from the International Space Station. That is how large and, just a, a thing in itself in terms of just the scale of this mine. So what happened in September 2025 is that 800,000 tons of waterlogged debris flowed into the open pit of this mine and trapped and killed 7 workers. So with this event, not only was there a loss of human lives, but there was also about a 35% reduction in copper production in 2026 expected, and a 2.5% reduction in the global copper supply, given that Grasberg mine generates about anywhere between 3 to 5% of global copper. So literally, anything with electronics, anything with wires, anything to do with the energy transition really requires the functioning of this mine. And unfortunately for 2026, functioning is going to be much less than usual because of this mudslide. It was catastrophic. So let's set the stage for what happened here. So Grasberg Mine is located in one of the rainiest places in the world. So this is the 2025 rainfall at Grasberg Mine in millimeters per day. And this is the usual rainfall at that location in Papua province in Indonesia. And so, one thing that you see here is just these rainfall numbers are astronomical. I live in the Pacific Northwest. I like to complain about the rain. After seeing these, I guess I shouldn't complain at all, ever. So, usual rainfall for this region is about 7 meters per year or 275 inches. And in 2025, it was even higher rainfall than normal. 8.5 meters over the course of the year, 335 inches of rain. Okay, so this mine, which our entire global copper supply really depends on, is located in one of the rainiest places on our planet, and 2025 was especially rainy even for this location. So looking a little bit more closely at this, let's sort of parse, what happened prior to the mudslide. So September 2025 was the mudslide, and the previous month saw much higher precipitation than usual. This is the usual precipitation, and this is the usual precipitation down here, and this is what we saw in August 2025. So this is what we're going to try to predict. We're going to say, when could we see that August 2025 was going to be extremely rainy? So, in other words, how well can we forecast an extreme precipitation month like this in this region? It turns out that we can do it pretty well. So, these are forecasts initialized in April 2025 that look at excess rainfall in August, September, and October 2025. So this is the usual for that time of year. This is the actual that happened in August, September, and October 2025. And this right here is the forecast. So you can see that the forecast was really, saying, yeah, these are going to be much rainier than usual months. And they were able to say that literally about 6 months early. And note that this comes really from the fundamentals. So at that time, we were in a very slightly negative Nino 3.4 index. I don't even know if we were calling it a La Nina then. And really, even right now, it's like La Nina in quotes because it's so weak. Either way, La Nina tends to push precipitation towards this region. And so, yeah, there is predictability. There's great predictability in the Nino 3.4 index, and therefore there's predictability for rainfall in this region, months in advance. Now let's look closer to the region, to the time of the rainfall. In particular, let's zero in on August 2025. So this is the usual August rainfall. This is the August 2025 rainfall shown in blue. And these are the distributions of the rainfall predicted in May 2025, June 2025, and July 2025. And you can see that forecasts initialized in May, June, and July all indicated that August 2025 was going to be much more rainfall than usual. The one thing that I think that's really interesting, so here I kind of zoomed in on these sort of different months. So here's the May 2025 initialization. I've kind of grayed out everything else. Here is the June 2025 initialization, the July 2025 initialization. And one thing I think is really fascinating that you can see is that like May and June really kind of nailed the number, even in the mean of the distribution, whereas July 2025, I mean, really suggests that this like August could have been even worse, right? Because it was literally predicting, yeah, there could be even more precipitation. The tail of this distribution is pretty extreme in July 2025 for the August rainfall. So, going really bullish in July 2025 on rainfall in this region should really have been an indicator that, August was going to be an extreme month. And what actually happened in August was a little bit better than potentially what could have happened. So actual precipitation was a little bit lower than what was predicted in terms of the extreme. So to recap, what we can see as the key takeaways here is that for the Grasberg mine mudslide, wetter than usual conditions were evident in forecasts up to 6 months ahead. And, another thing to really take away here is that just in general, there is excellent precipitation predictability in the tropics, weeks to months ahead, particularly for years where we have higher than usual or lower than usual precipitation that persists. So, what this means is like, I mean, there are just so many ways that these forecasts can be used. And so we should use them. We should use them. We should save lives. We should save our minds. We should save like our, global industrial production, including, the energy transition, our EVs, all of which require a lot of copper. Yeah, let's protect our natural resource extraction and make it so that it's actually robust to our changing climate and intensifying weather patterns. Um, Another area that I really want to emphasize here is that in real time, you can actually see us going through forecasts, particularly of Minas Gerais in Brazil. So we started predicting excess precipitation over this region over coming months since October 2025 initialization. So this is me in one of our webinars in November, particularly a webinar on mining, where I was looking at different regions in the world and noticing, oh, wow, this region looks really wet and there's major mines here. And I know that there are currently, some major issues with hydrology and water resources going on in Minas. And so, yeah, once again, we do really well at predicting precipitation in the tropics. Let's use it. Okay, moving on to case three, because this is what we do. We go through. So here, I'm going to look at the Arctic blast over North America, something that I think all of us, we might still be shivering in it in some parts of the country, if we're in the US or in Eastern Canada. So some background on this. This event led to over 100 deaths across the US and over 1 million customers lost power at some point, which is, dangerous when temperatures are so low. Over 10,000 flights were grounded over several days, and there was enormous volatility in natural gas prices at this time as utilities really worked, fiendishly to keep the lights on for as many folks as possible because lights mean heat, which is really critical when temperatures become Arctic-like. So, we have been talking about the possibility of cold snaps since September. And the reason why, in September 2025, the reason why we have is because the fundamentals this year, this winter, have really favored Arctic blasts. And this is because we are currently in a negative phase of the QBO. So, a negative or easterly QBO favors polar vortex weakening events. So here is a stable polar vortex. Here's a weakened polar vortex that either is stretched or disrupted in some way. And when these disruptive events happen, this is when you can get cold air from the Arctic moving pretty far south, and you can get warm air coming into the Arctic. And generally, these polar vortex events can be associated with cold temperatures over Eurasia or cold temperatures over North America. And so that has to do with sort of the shape of the weakening and how the shape of that weakening impacts the jet stream. And so, yeah, there's some details here of exactly how the cold snap plays out. But these types of weakening events are extremely predictable over the next few weeks. And so this gives us a tremendous amount of predictability in terms of understanding when cold snaps are going to hit. So, just a fun little image of the weakening event that occurred in mid-January that led to the end of January cold snap. So, when the polar vortex gets stretched or deformed, sometimes it can look like a jelly bean. This then impacts surface temperatures, usually with somewhere from a 1 to 4 week lead. So, and weakening events. We usually have like 2 to 3 weeks of lead time for those. So this is where we can really end up getting, a nice bit of lead time for cold snap events that, really stretch beyond our usual 7 day weather forecast horizon. So thank you, Stratosphere. So let's look at what these forecasts showed us starting from January 1st. So as early as January 1st, it was about January 1st where these forecasts, where this cold snaps first started appearing in the forecast. So this right here is the January 1st initialization. And these blue colors indicate, colder than usual conditions. And this was the January 8th initialization, moving up to January 15th. And then this was the initialization the week before the cold snap, which was January 23rd to 29th. And so, one thing that you can see is that over time, the forecasts really intensified their predictions in terms of how cold the cold snap was going to be. And that over time, they also shifted eastward. Now, this pattern right here, where the cold snap is really focused towards the east of the continent, this is very consistent with a really interesting Greenland blocking pattern that is happening right now. And so, this could have been something that, yeah, maybe we should have been able to see in January 1st. I could just say, like, yeah, models are not perfect, but it seems like it is something that we can do better even earlier, just given the fact that Greenland blocking is just really a major persistent pattern this year. Note also that there's a lot of uncertainty about what goes on in the American South and Southeast, right? So, and the models kind of got really wishy-washy at first. They're like, yeah, maybe there's some involvement with, the tip top of Texas. And then, later, about 8 to 14 days ahead, they were like, nope, not Texas. And then, a week ahead, just kidding. Texas is going to be really involved in this cold snap. So, yeah, there is often forecast kind of change as more information emerges, say, from the stratosphere in terms of the shape of the weakening event, of the polar vortex, and how that manifests in terms of surface temperature. So now, one thing that's really interesting is that if we think about what to expect over the American South and the Southeast, so here's the forecast initialized on January 1st, where instead of looking at the mean of the distribution, I'm looking at the 25th percentile of the distribution. And here, what you can see is something that looks like much more, kind of American South um, impacted. And so, this is interesting, right? That the possibility of cold conditions did actually start to appear near the tails of the distribution, even if it didn't appear in the mean until a week or two before. So here are some distributions. This is hot off the press. A huge thanks to Dr. Aiden for getting these for me this morning. And so looking at three different locations over our country. Here is San Antonio, Texas. San Antonio, Texas is super fascinating, right? Because so once again, the color codes are the same as what I used before. The 3 week ahead, 2 week ahead, and 1 week ahead forecasts are shown in these different colors. Technically, I think it's like 3.5, 2.5, and 1.5 weeks ahead. Forecasts are shown in these different colors. And so what we can see for San Antonio, for example, is that, the 2.5 week ahead forecast, or sorry, 3.5 week ahead forecast did show the possibility of a cold tail. The 2.5 week ahead forecast sort of changed its mind. And then the 1.5 week ahead forecast was like, hey, yeah, you guys better prepare for cold weather because it's very likely. And that is this deep red color here. New York pretty much was nailed very well in the tail, as well as even in the mean, a week and a half ahead. And Charlotte, North Carolina is super fascinating because it was pretty much like, the entire time the forecast was like, yeah, you're going to be colder than normal, you're going to be impacted. I have heard some things about how North Carolina just became a winter wonderland, during the time of this cold snap. And so, yeah, they could have gotten pretty good lead time on that in terms of what the forecasts showed. So, key takeaways here for this Arctic blast. Activity in the stratosphere provides great subseasonal predictability. And in fact, this subseasonal predictability, you can think of it as being extended even longer if you just know that the QBO is in a negative phase. Because if it's in the negative phase, you know that we are preconditioned for these cold snaps. And so you know that, the fundamentals favor them. And so it is very likely that, a major extreme event is going to happen over the course of the winter. Note that for the January 2026 Arctic blast, it first began appearing in forecasts on January 1st, 2026. Forecasts initialized at that time, so about 3.5 weeks of lead time there. And that impacts over the American South and Southeast only appeared near the tail of the distribution as early as January 1st, but really began to appear in the meat of the distribution much later, more like 1.5 to 2 weeks ahead. So this concludes our webinar for today. So you can find this and other webinars on YouTube. This particular webinar will be posted on YouTube by, I believe, the end of the week or the weekend. And we really look forward to seeing you hopefully at our next webinar where we'll talk about El Nino because it looks like we are moving into a moderate El Nino year. And so El Nino provides a ton of predictability as well as creates a ton of weather volatility. And so we will talk all about this in a couple of weeks when we meet again. So Thank you so much. And we are right at 10 a.m. So I'm going to go ahead and close this. Um, Okay, and then I got this question from Dr. Femi. Yes, Dr. Femi, we can totally share a bunch of sort of what we call hindcasts or back tests, and we can take a look to determine sort of how well our forecasts in general, long range forecasts do at different lead times. So would be happy to talk more with you about that. And yeah, it would be really fun to work together because I know we all want to make mining safer and more robust as our weather continues to change. All right, folks, thank you so much.